Oh. Hello, everyone.
Hey.
I see now it's recording from the beginning. We won't be able to joke around before the meeting starts anymore.
You know, it was bound to happen at some point, so it can never be too good too long.
We'll be able to do it. We just have to be okay with it being recorded.
Yeah, that's right. That's right. Well, if you're listening for the meeting now on the YouTube channel, I'm sorry you missed all the fun from the pre-meeting discussions. Hello, everyone. Good. Go ahead. Yeah. So we usually take a couple minutes to let people join the meeting, and then we start. I think we have quorum of people who are presenting or showing things today. So welcome all to the March edition of the monthly OpenLineage meeting. As a reminder, these meetings are recorded and they'll be archived with notes on the LFAI and data OpenLineage wiki. You'll find the notes there as well as the links to the recording if you want to check previous meetings you might have missed. And so, yeah, be on your best behavior because this is recorded. And first, I'll start. So we start the meeting with a quick round of introductions. And we keep track also of the member of the TAC who attend those meetings. And we usually expect you to quickly state your name, why you're here. If there's something you want to bring up or discuss today, we have a general discussion section at the end. And if you just want to listen in, it's fine as well. You don't have to bring a topic if you don't have one. So I'll follow on my screen, starting left to right. And I know Zoom doesn't show the same order to everyone, so we'll use my order to do that. So First on my screen today is Michael Robinson.
Hi, Michael Robinson. I'm on the community team at Astronomer. Nice to see some new faces here. I coordinate these meetings, and I'll be talking briefly about recent releases today.
Next is me. I'm Julien. I'm the lead for the OpenLineage project, and today I'll be talking about adding metadata outside of runs to the OpenLineage stack. Maciej.
Hey, I'm Maciej. I'm a software engineer at Getting Data and OpenLineage committer.
Tomasz.
Hey, I'm Tomasz Nazarewicz, and I'm also from Getting Data, also OpenLineage committer, and I'll be presenting today stuff related to JDBC relation integration with Spark.
Jakub.
Hey, so I'm Phil from Getting Data and the OpenLineage committer. I'll be talking about small improvement in Airflow.
Minkyu.
Hello, my name is Minkyu, and I'm a software engineer at Astronomer, and happy to see you all.
Anirudh.
Hi, I'm Anirudh. I'm a data engineer at a company called Grab from Singapore. And today I'll talk a bit about my latest contribution to OpenLineage and maybe also chime in a bit on discussions related to capturing column transformation from Spark. Happy to be here.
Welcome. Michael Collado.
Hey, Mike Collado. I'm a staff software engineer at Astronomer, OpenLineage committer. Just hanging out. See all your beautiful faces.
Willie.
Hello, everyone. I'm Willie. I'm the co-creator and project lead for Marquez. Also work with quite a few people on the call on data observability at Astronomer, and I'm a OpenLineage committer. I am very interested in the capturing metadata outside a run because that's very relevant for the Marquez API, which we've deprecated in favor of one day implementing what's being discussed here. So super excited to chat about that.
Shiri.
Hi, I'm Sherry Cabral. I am a product manager at Calibra, which is a data governance tool, and I specifically work on lineage for ETL tools. And I don't have anything I'm talking about today, just listening.
Hi, Sherry. Sam.
Hey, I'm Sam. I'm also on the data observability team at Astronomer, and I do front end, so I like to listen in and hear all the updates about OpenLineage.
Anne-Mary.
Hi, I'm Anne-Mary. I work with Hewlett Packard Enterprises. We work on a framework called Common Metadata Framework to capture metadata from AI pipelines. And today I'm here to listen more on OpenLineage.
Brad.
Hey, Brad here from Fivetran. Just here to listen today.
Atif.
Hi, I'm Atif, data engineer at Astronomer. Happy to be here and be a fly on the wall.
You're welcome. Prachi.
Hi, I'm Prachi. I'm a software engineer at Astronomer in the observability team. I'm here to listen in to the updates and see you all. Yeah.
And last but not least is Martin Fulton or Marta Fonta.
Hi, my name is Martin and I'm from Hewlett Packard Enterprise, working with Anne-Marie, who introduced herself on Common Metadata Framework, and I'm very interested to learn more about what your team is doing.
Welcome.
Thank you.
And so, so these slides, I'll go quickly. It's just a quick reminder. The slides will also be available on the wiki for perusing. This is where the main means of communication are. The Slack is the best way to talk to and ask questions. Today for the agenda, we'll have the announcements, recent releases, demo by Danny, but I don't see Danny here, so maybe it will be next time. A demo from Anirudh, and it's a pack agenda anyway, so maybe it's a blessing. We'll have the async operator support in the Airflow integration by Kuba, JDBC relation support in the Spark integration by Tomasz. Then discussion items, we'll have the gating column transformation metadata from Spark by Anirudh. And I'm going to talk about the emitting dataset job metadata outside of RunEvents at the end. So for announcements, Michael, you want to do this part? I think you had something to remind people about.
Yeah, just very briefly wanted to let people know about upcoming events in the community. Today, we have our first data lineage meetup in Providence, Rhode Island, which is very exciting. That's at 6 p.m. And Calibra is going to be there, represented by Shiri, which is awesome, and maybe more companies as well. And then Data Council Austin, also coming up at the end of the month. We have an OpenLineage meetup happening there.
And I'll be speaking.
And Julien will be speaking there, yes.
And just a quick question for those who can't attend in person, is any of that, can anyone attend virtually at the meetups?
I don't think there's an option to attend virtually, but I trust Michael and Sherry and others to share the good notes or about the conversation afterwards.
Yeah.
Okay, awesome.
I won't be able to attend this meetup myself, but I think there'll be good discussion there, and we can follow up on Slack.
And I'll be speaking at Big Data Tech Warsaw at the end of the month here in Warsaw. About column level lineage with Pavel, who's not here today.
Great. We'll add it to the slide so people can find this easily. Nice. Any other announcement? Okay. So recent releases, and this time we'll go a bit fast on this one because we have a packed agenda. And so, Michael.
Right, just very quickly, because we do have a lot on our plate today. For detailed notes, please consult the change log and the release notes. In 20.6, we had mainly changes to the Airflow integration. And then in 21.1, want to give a shout out to 4 new contributors to the project, including Anirudh, who's with us today, as well as Natalie and Quentin and Chris. And here, among other things, column lineage for JDBC relations in the Spark integration, which we'll be hearing more about momentarily.
You say JDBC so well.
Not easy.
Okay, so I think, yeah, I don't think Danny in the attendance today, so we'll move this one to next time. And I'll skip to the next item, which is demo of the custom environment variable support in the Spark integration. So Anirudh, I'll release the screen. I'm assuming you want to show something.
Yep, sure. Let me go ahead and share my screen. Okay, can everyone see my screen?
Yep.
All right, cool. All right, so basically what I've done is I just ran Docker Compose up from the OpenLineage, the repo. So it's within the integration/Spark folder. That's all I did. It's using the latest jar. So this is a very simple Jupyter notebook with like some simple Spark SQL for the demo purposes. So what I'll go, or rather, maybe I'll start off with what the contribution was about. It's basically about being enabled to capture custom environment variables from the Spark cluster. So this will be particularly useful when we want to add metadata to the Spark cluster and we want to capture it from the event so that we know where it's coming from and basically metadata from whatever we are trying to capture. So a very high level overview of the PR is that I added another class basically, which is the custom environment facet builder class to suit this purpose. So this class will extend from the custom facet builder class, which already exists. And the ultimate function of this class is to basically, as you might have guessed it, capture the environment variables from the Spark cluster. And currently in the case of Databricks, we are already capturing some Databricks specific variables. So this will not override it. Rather, when enabled, just serve as an addition to the variables that are already being captured. Cool. So now we can go ahead into the demo. So let me run this. So this just sets a environment variable called testvar in this environment. And I'll run this, setting up the Spark session. So as you can see, to basically specify which variables we want to capture, we have to just specify this Spark config, which is spark.openlineage.facets.custom environment variables. And we pass in a list of semicolon separated strings, which will be the environment variables that we're trying to capture. In this case, I just want to capture one, so I just put one, but we can add as much as we want. And I'll put the transfer type as console, so we can just log the events instead of having to send it somewhere else. And I'll set the log level to info. So I will not run these two cells because I already ran it. So it will throw an error when I do run it, but basically it's just creating a database called test and a very simple test table with two columns, column 1 and column 2. So this one, I will basically create a table clone on this using the ctas command. And when I do, I should see that OpenLineage will basically capture like a start and end event. So this is the start event. And if everything works correctly in the start event, I should be able to see the test var being captured already. You can see it under environment properties. Yeah, so that is basically the gist of this functionality. And I think this concludes the demo as well. Any questions? Any comments?
Great work. Can anyone accidentally put like an environment variable that has like a secret or something more like credentials in there?
You mean over here, like where you specify it?
Yeah.
Yes. I think you can. So yeah.
But I think the point here is you have to explicitly pick which variable you want to export.
Mm-hmm.
So you won't inadvertently do that, right?
Yeah, fair enough.
Yeah, you don't capture like whole environment variable dictionary, just you have to opt in for some variables.
Okay, that makes sense. Very cool.
Great.
Awesome. Thanks. Thanks so much. Okay. Any other questions? Okay.
Well, I do have a quick one. So this was your first commit. What was the experience like? It was all positive. Did you, interact with the community, and was that for the most part a welcoming experience?
Yeah, I think it was really great. I got a lot of help from, I think, a lot of people, especially I think Powell. I don't know if he's here. So I think it was really great. Yeah, it was a great experience overall. And I think just to say as well, I think I'm a great fan of OpenLineage in general. I think it's really great software out there. So it's very useful as well. So yep.
Awesome. Sorry, 1 second, I lost my slides. I'm getting old. It's like I left them somewhere. Here we go. So next, thank you, Anirudh. And next we have the async operator support in the Airflow integration by Kuba.
Okay, so I'm Kuba from Getting Data, and I'd like to talk about support of async or / deferrable operators in Airflow from the OpenLineage integration. So just to introduce the topic, Airflow now has a notion of asynchronous operators that does not block workers. And the process is that a task instance gets to a point where it has to wait, then it defers itself with a trigger that is picked up by a trigger process. The trigger is run, and then the task is, let's say, resumed. And it turned out that each time the task was resumed, it was treated as a new start event from the OpenLineage. And the fix was to detect whether the task instance is deferred, and also to set a new, let's say, the new way of run unique ID. So the issue was not to send, or maybe the fix was to set the deterministic ID for each run, which is basically a task or operator in Airflow, composed of task ID plus execution day plus try number. And this was introduced in some other PR previously. And the second is, as I said, to detect with checking if next method attribute exists in task instance. And if it does not, it means that the task is runs from deferred state. So in such case, we don't want to send any event, and that was the fix. So now the start event is only sent the first time whenever the task is queued, no longer when it resumes. So that's it.
Nice. And yeah, like async operators is the new thing in Airflow, which is helps saving resources and worker time. Okay. Next, we have the JDBC relations support in the Spark integration by Tomasz. And I think Tomasz, do you want the screen?
Yeah. I'm gonna take over.
Okay. Let me stop sharing.
Okay. Here. All right. So the standard question, can everybody see my screen?
Yep.
All right. So I'm Tomasz from Getting Data, and I wanted to talk about the JDBC relations support in OpenLineage Spark integration. So what is that all about? The newest feature that is in OpenLineage since the last version is that we in the event that we sent the information not only information about JDBC sources, not only if they are tables, but also we support queries. So up until now, if you defined the data source as a JDBC table, that was fine. But the moment you tried to do a query, then it just return the, like in the event, you only had the complex word as a description of the source. So that was not really that helpful. And later we got the SQL parser, which is the Rust library that we some time ago integrated into OpenLineage. And with that, we are able to parse the information from the query, and with that, give some more information about the data source and about the column lineage. So, so right now, okay, I'm gonna go to the next slide. So that's basically how it works if we have some Spark data frame, some operations defined. Here we have basically two iceberg tables that are joined to V1 and V2. They are joined to create a V table, and the V table is a joint with J, which is JDBC source, which is defined as a table here, and that creates the data frame. So in the Spark plan, we can see all the fields that are present in the sources, and it's all fine. We have a table for JDBC because it's all well supported for the iceberg tables. We can clearly see that all the source tables are listed as a relation V2 with all the fields defined, and for the JDBC relation, we have two fields that are present there, which is fine. But the moment we go with query, like the one that is presented here, which is some joins, two other sources, some concat function, like the query plan still only contains the K and J fields, which are really not enough because they do not correspond to the external source, like to any table, nothing. So what we now did is extract the information from the query, parse the query, and from that, we get the information like here that we have JDBC source 1 table and JDBC source 2 table, and we have the lineage information about each column that was defined inside the query. So with that, we have our normal column lineage mechanism that relies mostly on those numbers hashtag something, which are the expression IDs. And basically what we do, we first parse the query to get some tokens, and then we map them to assign to them some expression IDs. And with that, we can treat them as normal Spark columns, basically. And that is all collected, and it is sent as a part of a run event. Here we have example, which is generated by one of the integration tests. And here we see that we have the lineage information about the field, the final field K, which is defined here as a number 14. And that comes from the iceberg table. And for the value field, we have 4 fields as a lineage, which corresponds very well to what is actually the situation here. And for our inputs, instead of having only complex keyword, we have defined JDBC source 1 and JDBC source 2, and which columns we have taken from that source. Unfortunately, yeah. Oh, sorry, there is a typo here. We are not all the way there yet because the only information we are getting is the information extracted from the query. So if somebody gets a select star from expression, then we cannot parse it because the parser cannot, like, it doesn't have an access to external data source. So it's just not the information it has. And the other drawback is that all the data types has to be inferred from the data types that are present in the data frame that is the result of the query. So that is not exactly accurate, but for now is the best we can do. And we cannot get the complete structures of the data source that we query. So like no connection to external sources yet, but that's that. And yeah, I think that is it.
So what you mean is you can get the table name, but you don't get its schema, right? And you know the columns only if they're specifically defined in the query.
Yeah, so yeah, that is the one thing, and the other is because here we have the like one function that because if you do select star on topmost select, that's one thing. But for example, if you do like select star from one of the tables that are joined, for example, then you completely lose any lineage, right? Like there is like no coming back from that. But basically, yeah, so no information besides the things that are clearly defined in the query itself. So if you want to have an information about all the fields, you need to just use exactly all the field names, and then it will be available.
That makes sense.
Yeah. All right. I'm gonna stop sharing now. Where is the button to do it?
Hi, just one question. Sorry, can you hear me?
Yeah.
So what happens in the case of if we're using a view or something? So will we be able to capture I'm guessing we'll be able to capture the underlying tables of the view, right? Since it's coming from the query.
So not like, so here, not only you will not be able to get the information about the underlying table that are creating the view, you will only get information about the columns that you are actually getting from the view. Because like I think what you're asking is that if you have a view and it consists of some tables underneath, will you see the structure of the view or the tables underneath? And that's way ahead. Right now, if you, for example, have a view that has 10 columns and you will do select for 4 of those columns, then you will, like, from the OpenLineage perspective, you will only know about 4 of those 10 columns because they were defined inside the query.
Got it. Yeah, makes sense. Thanks.
Okay. For some reason, I can't see the button to stop sharing.
It's not just me.
Have you tried turning it off and on?
I can turn off the computer if that's what you're asking. Oh,
that would work. You would stop sharing. Here you go.
Yeah. That was the drawback of having multiple screens. It was on the other screen.
Okay, any more questions on this topic? Otherwise, we move on to the discussion items. So we had 2 discussion items for this. So there's the new feature proposal, track column transformation inspired by Anirudh, and the spec change proposal, emit dataset, and job metadata outside RunEvent from me. So let's start with, are you ready, Anirudh, to
Yeah, sure. Yeah, so basically the crux of this proposal is basically right now, what we can do is we can capture column lineage from Spark. So we know what columns are upstream of what columns and what columns are downstream of what columns, but we don't really have an idea of the kind of transformations that are being done on the columns. And I think having this information will I guess, augment the entire column lineage greatly, right? So it's really useful to have this information as well. So just wanted to have a discussion about whether there is an idea to support this down the road, and if so, how we should proceed with it, and like whether we should start planning for this, how we should start planning for this, just general things like that. So yeah, please go ahead.
But I can give an element of answer, but please, anybody else feel free to answer as well. So when we define the column lineage facet, we did put the beginning of that in there. So there, I think, let me actually pull up the column lineage facet spec and see. And show that. So it probably doesn't go all the way to what you're describing, but I think there will be something, right? So in the column lineage facet, so there's the column lineage who knows what field, what column in the output depends on what columns in the input. So it's kind of just, there's a dependency there. So that's the first element, right? So column A is dependent. Actually, there's an example here. So if we have the input and output schema defined here, like the column lineage saying that this column A in the output is dependent on column IA in this table in the input. And then the other type of information we added, we have transformation type and transformation description. So transformation type right now defines two things. So basically, to simplify, and this is useful, identity is helpful to say, well, there was no transformation. This is actually the one column from the input, and it has not been changed. So it's useful to track, you know, IDs or things not being transformed and carrying over from one table to another. Masked is useful in the case of privacy use cases, when people want to know, well, this column is derived probably from the ID of the person or the name of the person or the email address, but I want to know the actual email address is not in the downstream table, right? So it is derived from, but the information is not found, right? Because it's been hashed using a cryptographic hash or something. And so, and the transformation description field is meant to be kind of a readable field. So you could actually, you know, I think in the current definition of the facet, you can just put a string representation of the transformation here. And this is supposed to be a human readable field, right? Like it's kind of an information. And maybe you would write, this field is concat A and B or something, right? You could put a text representation of the expression here. It's not meant to be machine parsable or any kind of logical plan or anything. It's just meant to be a user readable element. So that's how we define it so far in the facet. So I think in the current definition, you could totally add information from the Spark logical plan there if you wanted to put the expression. We don't have a more fully specified transformation, right? If you want to have a machine readable representation of it, this is not included in the spec at the moment.
And my question is that, can we even describe like what the transformation is in general case? Because it seems to me that we would have to put like abstract syntax tree of the transformation there.
Most of the time you can have, there's like a two-string version of those things, right? So we could make something that is readable. I think if I reuse Tomasz's example in the slides, let me see. Right, so here, when you have a concat JS1, J1, J2, something, that turns into some kind of tree in the logical plan. There's an AST somewhere. So you could make a string representation of this, right? Maybe it would look.
Yes, but if you have a CTE and you concat it with another CTE and then you do something else with the resulting query.
Yeah, so yeah, maybe you just do two string of, I guess it depends a bit on the Spark implementation. It depends if we want something which is the exact transformation or some kind of explain like thing that shows you what has been done, right? If it's for user information purpose and you want to verify, sometimes people want to verify that the metric is computed the right way, right? And you can like see it through this metadata. That could be useful.
Yeah, exactly. I think the idea of metrics is also kind of what would be like the most immediate use case, I think, where we just want to see how, or rather what formulas are used to kind of obtain some columns, especially if they're like some business metrics or metrics in general. Yeah.
So yeah, this string could be like a summary of what the expression is. So you could turn the AST into a flattened view of it. And if there's several layers of transformation, maybe it's they get concatenated in some way. I don't know. I don't know what's the best representation, but I think it could be done, right? And this facet definition could be extended, right? So if there's like, this is the fields we define. So yeah, I was giving the example here, or it could be this as human readable description. So I think you could do something with the current definition. We could add fields if that help with this. It's like there's more of a tree structure that could be added. This could be defined.
Also, just to say that human readable doesn't mean that it's not machine readable. It just means that it's not expected to be a certain value type. So if you have something in your organization where, I means identical and, A means aggregation or something, right? You can certainly have a machine process this.
Yeah. Yeah, it's just we made it human readable because that way we don't have to guarantee that you can parse it back and retrieve the exact, transformation. Because that's more complex and it depends on all the models of all the engines we may be looking at.
And also, like, I think another case would be if there is like a conditional in the query. So in that case, what would be the, I guess what would be the right column lineage, right? Technically, it could be either of those columns. So would we capture it based on which path the query takes in at that point, or should we have both since they're both?
I think they would be both, right? Because that means this column, if we look at the column, each value depends on one or the other, but the column in general depends on both, right? Because the values in the column depend on either one or the other. So we would put both in this case. Yeah, and since the transformation description is human readable, right, you could generate some text that explain this if that's something you want to do, right? I suspect this makes it a lot more complicated, right? To interpret the logical plan, to decide if this, then that. I mean, it's still an expression, right? You would have like what you would use coalesce or something.
Yeah.
You would have a coalesce expression in your description or something, for example.
Right. Yeah.
So.
Is there a way to do a column level lineage where an input column affects an output table? And what I mean by that is, we call this an indirect lineage. So if you're doing like a filter, if you're saying, insert into the target table, select star from source table, or not star, but select, column 1, column 2 from source table where column 3 equals something. Right, so column 3 affects the table, but it doesn't show up in the table, in the output table. Is there a way to do that yet in OpenLineage?
Oh, so you're saying like this, the select doesn't include columns that are in the where? Is that what you're saying? Sorry, there's a bit of background noise. I'm not sure I heard everything you said.
Yeah, basically there are columns in the input that aren't in the output.
Yeah. So like an example of that is you used it in the where clause, but it's not in the select clause. Right. Just so
exactly.
As far as I know, current implementation does this actually. It doesn't include in column level lineage
it doesn't
the unused columns.
Yeah.
I'm not saying there are no bugs, right? But
it doesn't. Right now, it takes into account what data it is derived from. So that's right. If you, I guess maybe we need some specific examples. I think that could be added.
I think even in case of a join, right? If the joined column is not specifically in the select clause.
Yes, that's correct. Right. So it's focusing on where is this data coming from, not how it was selected.
Mm. And I'm just curious. So currently, if I create a foreign key, then does that capture column lineage?
So if you create a foreign key, does that capture column lineage? No, I think the column lineage focuses on the transformation.
Okay.
Right. So if you create table as select, right, is going to capture the link between the columns it's read from and the columns it brought to in the output.
Yeah, I see. Yeah, I think it's a great point that she mentioned in the chat as well. Very useful for impact analysis. Yes.
So Sherry was saying, yes, the use case for that, by the way, is impact analysis. If you get rid of the input column, the output table will be affected and the query itself won't work. Yes, that makes sense. I think, yes, like right now, right now the column lineage implementation that have been focusing on where is the data coming from, rather than fully column analysis, impact analysis. That makes sense. I think that's something we could, in this definition, we could add more metadata, for example, in the field itself, right? So you could have a type of dependency, right? Is this a data dependency? Is it a selection dependency? And kind of have more precision in there and add this information. I think that's a great point. Yeah. Cool. So on this topic, I think, if someone is interested in working on that, I think that makes sense. And the way this works, you can just open pull requests or open an issue and start the discussion around there. And moving to the last item. So we have 12 minutes left. So I think I'll get started this. So this is based on discussion that have been happening for a while now. So it's about emitting dataset and job metadata outside of RunEvents. So we've been, and I think, Michael, this doc has been shared a bit, I think, and this Google Doc will be shared more as well. So Machi had been working on a proposal and I've added more color to this. And so there's a working Google Doc that people are welcome to comment on. And so I'll give some context to this. So in the current events, right, currently OpenLineage defines RunEvents, right, which describe our job is writing and output dataset while reading input dataset. So it's really about a transformation while it's happening, right? It describes the operational lineage. It captures it as the transformation is happening, and it enables precise metadata of that transformation. And it's specifically about affecting the data itself, right? Reading the data, writing, and the actual transformation. So, and they capture metadata around this in a couple of ways. So they capture metadata about the run itself, this particular transformation, and also metadata that is more static and related to the job and dataset. So what I mean on that, on the job side, there's some job facets which describe the current state of the job. So example are the current version of the job, like the Git shot. So this is more static. Like if a job is running every hour, most of the time the SHA doesn't change, and sometimes the version of the code changes, right? So that's a more static metadata. And there are also run facets that describe the current run, right? For example, in some cases, we can capture the query profile after the query is finished. How many cluster milliseconds have been used, you know, if you're interested in the cost of a run, like things that are specific to that particular run of the job. So that's the difference between job facet and run facet. And on the dataset side, we have a similar distinction. So dataset facet are about the current state of the dataset. Like for example, what's the current schema of the dataset is that's not expected to change every run. It changes sometimes, but it doesn't change every run. So dataset facet are the more static attributes of the dataset. And then you have input and output facet that are related to how that particular run is accessing the dataset, right? So it's metadata about, for example, how many rows were produced in the output by this particular run, right? And if, for example, if you're using Iceberg, what particular version of this table we read from, what particular version we produce when we wrote to the table. So keeping track, so it's the same distinction then between job facet and run facet. Dataset facet and input and output facet are the same distinction. And so we capture information about the transformation, but we don't enable capturing those more static information of the job and dataset when they're not running. And so that missing some use cases, right? And so this is what the proposal is. And in a previous meeting, Sherry had brought up some questions about how do we model in OpenLineage, you know, if you have a BI dashboard, or if you have a logical view in a database, right? How do you capture all those things that are more static, right? Like we want to define this definition. There's this view. It's depending on these other tables, or this dashboard is reading from those tables, but we don't necessarily want to capture it as every single access to the dashboard, for example. So the goal here is to be able to send events about those static aspects of job and dataset. So basically, you should be able to send job event and dataset event and send job facet or dataset facet without having to wait for a run to happen, right? So those things should be, you should be able to emit this information about the job independently of a run. For example, if we talk about the current version of the job, if someone redeploy a job, let's say you have an Airflow DAG and you're doing a redeploy and it has not run yet, you should be able to send an event that says, hey, the job just been redeployed. Here's the new version of the code facet, right? And you capture it at this time. And for example, if a job has just been created, it's deployed for the first time, the lineage system will know about it before it has run, and it knows that it exists, right? And we can do the same thing for a BI dashboard or a logical view as well. Or sometimes when we bootstrap the system, we could look at all the tables that exist in the database and create them as dataset with dataset facets that have a schema, even if we're not aware of anything that has read them or written to them yet. So there's some of those aspects. And so for that extension, we propose to expand the current run event to enable describing this static lineage. So I've been calling that static lineage with, like, you know, static analysis is the thing is not running, but we can make assertion about either its lineage or other related metadata. like typically other use cases that people have asked about is, I want to assert the ownership of this data set. And so there's a ownership facet that goes to this data set, but this is something that's defined outside of modifying the data. So it's not part of a run, but we can say who owns what. So currently we have run events, and the way run events work, they have a run, and like if you've been in these meetings before, you've seen Sherry went through that and was asking what's required, what's not required, and something. So I spent a bit of time like going through a bit on describing more like what we currently have and what we could add in there. Sorry. Okay, sorry, I saw someone had a question. Feel free to ask questions. So in the current run events, we have a run, which has a run ID and run facet as just described. There's a job, which has a job ID as namespace name and job facet, right? So this is the recurring job, and there will be a new event for every run of that job, but this job information is more static. And for each input, we have the dataset ID, which is the namespace name, and dataset facet and input facet. So the same information, like this is more static metadata, but we inspect it as the job is running. And this is the metadata that's related to the run, which is like what partition did we read from, or what was the where statement when we read, or what column we read from. And then for each output, we have similar thing, except it's dataset facet and output facet. So we're proposing to add something like having the ability to send dataset event with an ID and dataset facets, and job event, which have a job ID, but no run ID, obviously, but have job facets and no run facets, obviously, because there's no run. And for each input and output, same thing, having optional dataset facet. But you would not have input facet or output facet, or you would not have run facet, because all those describe an actual access to data. This doesn't describe access to data, it describes a static lineage dependency. And so in some cases, you could say, oh, this is design lineage, or in this case, I would describe it as static lineage, because OpenLineage is meant to introspect and figure out what is deployed in production, right? Like this BI tool has been created, or this view has been created, and that's we capturing this information here. And so it's not like someone put the lineage as it ought to be in a system. It's more about inspecting what's happening, what has been deployed. And I'll stop there. There's more discussion on like how you decide what the current version of a dataset when the dataset has been deployed. So I did some more discussion here. And then there's a discussion on, do we want to keep the spec backwards compatible or not, right? Because the way the spec is defined currently, it's kind of expect only run events. So we would have to shoehorn a bit other type of events in there, because it's not been really planned from the beginning. So there's a bit of a discussion, should we, rip the band head and just make it backward incompatible but clean for the next iteration, or should we try to make it backward compatible? And there are some options and there are trade-offs in there, including like readability of the spec and like easiness of implementation or easiness of use for users. So I'll stop there and ask for question. And of course, this is meant to be just the framework to enable a whole bunch of other stuff. Any questions?
So for the dataset version and schema and all that, right? Will it be supported for different data formats, like Delta, Parquet, Iceberg, all of them, or are we aiming for one type first?
Yes. So the facet notion is very flexible. It lets like define those things independently. So it's definitely meant to have versions for all of those things. I think for now we did we do more than the Iceberg integration so far?
Well, Delta is also
we did Delta
from Spark.
Yeah. So we both captured Delta and Iceberg at the moment. Thank you, Maciej.
Cool. Okay.
But yes, if there are others, they're meant to be captured as well.
So for the schema, right? If so let's say in case of Parquet, or if it's connecting to a HMS or something like a Hive Metastore, then how would the schema be captured? Like where will it be captured from?
Where the schema, so currently the way this work, often we query the so in Spark, I think we get the schema from the logical plan. I think is what it is. So, you know, when in Spark we have a query execution listener and we see the logical plan, and the logical plan already has this information in it, so we get it from there. In other cases, for example, when we use a SQL parser, like if you do a SQL query in Airflow, for example, the way this works is after the query has run, so we've parsed the query to know what table you queried from, and then we do a query to the information schema to get the schema of the tables from Snowflake. And I think that's one of the things that Tomasz was mentioning is in Spark, we don't do that because we have access to the query, but we don't have access to the connection anymore, right? So we can't query the schema in the information schema, which in Airflow we can, because after your task is finished, we still have access to the connection. So we can issue information schema query to get the schema.
Yep. Yep, got it. Thanks.
I know we're out of time, but I have a bunch of questions on it. I mean, one in particular, so the static notion of lineage, are we still going to have to, so Marquez being one of the backends, do we still have to display the lineage? Because one of the key things for Marquez is that the job has to be completed. So in this case, does that mean that we're getting data set events, we're getting job events, but we're building the static lineage on the back end and still, yeah.
I think it fits in the Marquez model, right? Like, so in Marquez, you used to have the ability to create a job and to create data sets. So in Marquez, you have two levels of lineage, right? You have the run level lineage, when you capture for every run, what version of a data set it read from, what version of a data set it produced. And there's also a more like static level, where it's like this job is running from this data set. So in Marquez, you can still update that and update dataset version and job version based on that. So there's no run connected to it. But I think the Marquez model supports it.
Yeah, which is funny. That's what we were doing before. You know,
yeah, this is a missing piece in OpenLineage.
My head's gonna explode because like we kind of went, was like, oh, this is too much work defining data sets, attaching them to jobs, and now we're kind of going back. But I think it's important to support both. It's just not a simple. It needs some discussion. I think I'll comment in the doc.
Yeah, this is just the beginning of the discussion. So
Sure.
I put the link to this doc in the comments for this for this call. It's going to be in the notes. We'll share it more on the Slack, and this is really meant. So there's been a bunch of discussion happening, and you know, in this meeting previously, in the Slack, on Google Docs, on other features. So wanted to write down kind of a summary of what the current thinking is. I think a big part of the discussion is how do we actually implement that, and probably describing more the use cases. And so, you know, this is something we worked on this week to clarify. And I think at the meetup, probably Michael and Sherry and others who will be there will have the opportunity to discuss more of this.
And one last question: is there a timeline for when we want the discussion to be wrapped up, or, you know, is there a timeline for the events that you're proposing to be in place and defined?
Not yet. There's not yet a timeline, but I think is to reach enough consensus in the community, making sure like if people have objections or things that have been forgotten in this model, they can speak now. And then once we have a good consensus in the community and we all think this is the right thing to do, I think we can start like really having a timeline on it and make it happen.
So from my point of view, it's important to hear from enough, people who consume OpenLineage data, since this is like our first possibly breaking change. So
maybe we'll say we don't want a breaking change and we make it work. There are ways to make it work in the current spec. It's trade-offs here. So
it still relies on consumer behavior that is not like codified. So it kind of is and isn't breaking change in a way.
Mm-hmm. Okay. So on that, I apologize. We're 4 minutes over. I see we lost a couple of people. Sorry for going over the planned time. And thank you all for joining. As usual, the best way, if you want to follow up on those discussions, if you have questions, if you have opinions, feel free to comment in the doc or Slack. The OpenLineage Slack is the best place to follow up and to get a hold of the people to do so in this meeting. All the notes will be on the wiki, and you'll find the recording as well. And we'll see you next time, and see you on Slack.
Later.
Hey, folks. Bye.
Yeah.
Bye-bye. Thank you all.
Yeah.